Next, we have our second workshop for the day, and we have two individuals from Mathworks, Gabby Adayano Bayo, as well as Neha Sardesai. Both are senior application engineers in education, where they work with academic customers to help provide them with support in terms of creating strategies and trying to explore how they can use the Mathworks tools to help implement a variety of tasks. Each of them are WIDS ambassadors as of 2021, and I'm proud to say I'm a colleague of theirs as well. They are going to be presenting the following workshop, Low Code AI, Making AI Accessible to Everyone. Please welcome Gabby and Neha.
So we'll be keeping an eye on the chat as well. And the way this presentation, this workshop is going to go is Gabby and I are going to sort of jump in here and there and just take this presentation and workshop in this 1 hour that we present. Lou very nicely introduced us. My background is I have a PhD in electrical engineering. My focus was biomedical instrumentation, and I've been working at Mathworks for the past 5 years. It's been an interesting ride, and I'm absolutely loving being a WIDS ambassador. Women in tech, women in STEM is a very personal and deep issue for me, so it's always great to be present. Gabby, do you want to introduce yourself?
Thank you, Neha. Yes, so my background is in mechanical engineering, and I have a master's in biological systems engineering, where I focus on water and soil resources. And like Neha, I'm very passionate about making sure that we have a more inclusive field and have more women in STEM and engineering and data science in general. So yeah, I'm delighted to be here. So Neha, if you want to start?
Yes, so let's move on. And we have a lot for everyone to do today, so I'm going to move along quickly. If you have any questions, concerns, post them in the chat, post them in the Q&A, and we're going to try to get to as many as possible. So if you can see on your screen, I'm going to sort of lay out what we're doing. It's sort of like a preview to the workshop for today. Have you ever wondered how your smartwatch knows when you're sitting, standing, or walking? You know, if you have an iWatch, you know that every 10 minutes before the hour, it always pings you that, hey, it's time to stand up, get that 1 minute of walking in. Well, that's what we're going to figure out today. And we are going to teach you how you can use machine learning as well as deep learning methods to do the same. Now, in today's agenda, we're going to focus first a little bit on the fundamentals of AI. There are about 400 of you or 450 of you last I checked. So I'm not going to assume everyone is, on top of their AI game. So we'll talk a little bit about some of the basic concepts. Then we'll walk into the machine learning example, after which Gabby will walk you through. Then I will walk you through the deep learning example, and you'll be doing these along with us. And finally, Gabby will give you some more information about further resources. We will be providing all of the links and all of the exercises that we run today to you, either during the session in the chat or after the session. It will be available on the WIDS website. So let's start off. And some of the outcomes that you will know from today's workshop, as everyone knows, 60 minutes, 58 now that I'm looking at the clock, are not enough to give you a big perspective on AI or to go like really, really deep. But as of today, you will know some amount of fundamentals of AI. You will learn to design and train AI models with some interactive tools which are available in MATLAB. And then we will also, if time permits, show you how to automatically generate the code for reuse. So let's start off with the most important question of all: what is AI? And there's a timeline associated with it. So back in the 1950s, it was defined as any technique that makes machines mimic human intelligence. And that was a fairly broad definition. So in the 80s, we tried to streamline it a little bit with the concept of machine learning. Now, machine learning is nothing but statistical methods that are going to enable your machines to learn your tasks from your data without explicitly programming. And finally, in the 2010s, we came up with deep learning, which is a subset of machine learning, wherein we now define neural networks with multiple layers that learn representations and tasks from the data directly. You do not need to tell these networks explicitly what you're looking for. So let's start out with the different types of machine learning. These, you will need these as we go along with the exercises we will be performing. So starting off right off the top of the hat, machine learning you can think of as unsupervised and supervised, where an unsupervised machine learning discovers the internal representation from your input data. And I'll talk about it with an example. Clustering. So if you think of clustering, you're going to be segmenting your input data based on how you place it on a graph in different dimensions and how you look at it. So for example, if you're looking to classify, say, in today's example itself, whether I'm walking, sitting, or just lying down, if I have 3 distinct clusters of the data that I've collected, well, I know that one of them is representing walking, one of them is representing sitting down, and one of them is representing laying down. So that is clustering. Now, let's look into supervised learning, which is defined by 2 different methods, which is regression when you're working with continuous data, examples, weather prediction, stock market prediction, and classification. The most standard example is classification of cats and dogs. For some reason, this is the multiple deep learning examples start out with how you classify cats and dogs. I think it's the most fantastic method. But you can also think of other examples of how you would classify different techniques. One example that I can think of out of the field is if you're looking at chest x-rays, how do you classify if a person has pneumonia versus a person who's got a healthy lung? The distinction can be done using the supervised learning classification. Now let's go a little deeper. Now your machine learning with all these different types of learnings is going to have different algorithms associated with it. For example, in clustering, you have your k-means, Gaussian mixture, and so on and so forth. These are just different statistical methods, different equations, if I may call them that. A very simplified version of it is just different equations that you're using to work through your classification or your regression. Similarly, with regression, you have SVMs, you have the nearest neighbor algorithms, and classification. Again, you have SVMs, discriminant analysis, and so on and so forth. Now, a section of this is deep learning, where you're using neural networks, which is going to be the deep learning bit. So you can think of machine learning as a rectangle, and your deep learning is a slice of it, like cutting through it, or a subset of machine learning, if you'd like to think. Now, there's always a question, how do you distinguish on a fundamental level between machine and deep learning? The way I like to think of it is, example, you want to classify different types of vehicles, your cars, trucks, and bicycles. How would you classify them? Now, one way I can think of these classifications is number of wheels. Another way is size. Something else I can think of is whether windows are present or not present, and so on and so forth. If you just think of size and wheels, these are the features or predictors that you tell your machine learning algorithm to look at in order to distinguish your images into car, truck, bicycle. So essentially, you need some sort of domain knowledge. You need to know that a car has 4 wheels, a bicycle has 2 wheels, your truck has, well, more than 4 wheels, right? Whereas if you're looking at a deep learning neural network, what you're looking at is a lot of data, but you don't need to point out to the neural network that look for number of wheels, size of the vehicle, and so on and so forth. The deep learning neural network will do it on its own. Okay, I hope and one of the distinguishing factors is for deep learning, the more data you have, the better it is. For machine learning, you can have a you can have some amount of data, but you can work with it in order, and then use your domain knowledge in order to make the predictions more accurate and more robust. All right, so that's a basic description of a 10-minute, insight into machine and deep learning, how you distinguish between them, what it is, and how you run them. Now, if you have any questions, I'd encourage you to post them in the chat, in the Q&A session of Zoom. But otherwise, I'm going to sort of hand over to Gabby, and she can take it from here. What we're going to do today is we're going to do human activity classification in the workshop. we're going to take activity data from the sensor is on your cell phone, gyroscope and accelerometer, and then we're going to use machine and deep learning techniques to classify our movements, our activity, to walking, climbing upstairs, sitting down, standing, and lying down. All right, so I'm going to stop sharing. Gabby, I'm going to let you take over.
Thank you. I'll share my screen in a quick second. And in the meanwhile, I'll share the link with instructions in the chat. Okay, give me 1 second because I'm not sure. And can you confirm which screen I'm sharing? I'm sharing my slides.
I can see the instructions. I can see your instructions. Yes, so the slides.
Okay, perfect. Thank you so much. Okay, so since we're getting our hands dirty doing this exercise, we're going to follow a few steps. Don't do them yet. Let me go through the steps and then I'll give you a few minutes to do that. So first, we're going to be using Google Chrome since it's the preferred platform to use for this workshop. And if you don't have a Mathworks account, you'll have to create one. And if you do have one, make sure that you remember your password. Sometimes we find in these events that people have forgotten their passwords, which is totally fine. You can just reset your password. And then we'll copy the material. So these are stored in a drive called MATLAB drive. And one thing that is really important is that you copy these files. So you'll have the two options, but I want you to copy them because that way you can modify the files, and that's what we want you to do, right? We want you to be able to own that file and play with it and make all the changes that you need. So I'll give you a couple minutes to do that, and we'll be here if there are any questions, any issues, let us know. I pasted, yes, we pasted the link with the instructions. Let us know in the chat if you cannot access it, if you have any issues. And once you're done, please raise your hand. There's a button here on Zoom to raise your hand, so that way you can see who has finished. So I see 2 people have already raised their hands. That's awesome. You guys are really fast. Nice. We have 17 people raising their hands. It's quickly growing. Okay, so if you have advanced with that, since in the link there is a different set of instructions, you can move on if you like. Otherwise, we can just do this together, the 2 next steps together. Done and ready. Excellent. Okay, I'll give you an extra minute or 2. We have to make sure that everyone has access so you can follow along. Done. Excellent. Thank you. So Madhuri, if you can, I don't know if you have raised your hand, but if you can do that on the on the Zoom option, that'll help us like visualize like everyone in one place. Can you? Okay. Yes, I can paste the URL there in the Q&A. So it's also in the Q&A as well as in the chat. Okay. So we'll move into the second instruction, but since you have that link, you can, if you're behind, that's okay. You can just follow the instructions there. But the second thing that we need to do is to access the license that we have created for this workshop. So you'll see this link is also on the set of instructions that we shared, and you'll click on Access MATLAB Online. And one thing here is that you'll have to log in again. So I hope you remember your password. And after that, we'll be able to, it will open MATLAB Online, which is a platform that we will be using for this workshop. So I'll check the Q&A also and see if there are any issues. And this should be real quick. Shouldn't take more than a minute. And once you're done, you have done that, we will open the first exercise, right? So you'll see that there's a tab on the left. You'll see MATLAB Online, and you see a tab on the left that says current folder. I want to make sure that you double click on that folder. So where it says WITS 2002 low code AI, and then you select the one that says ML at the end, right? So human activity classification ML, which means machine learning. Yes, so Anita says, just created my account. Awesome. Sorry to bother. Can you please share the MATLAB link in the chat? Yes, we can do that again. I think Lou just pasted it. Anita, can you please help me the next step? Yes, so the first step was to create an account, right? So once you have done that, we'll have to launch MATLAB Online. And the resource that we have pasted in the chat looks like this. So you can follow along, and it says, okay, create the account, then how to copy the materials. Let me zoom this in. And yes, and then use the activate the Mathworks license. And I think actually these are flipped in here, but it's fine. Like it shouldn't be an issue. Just that create the account is the first step, and the other two, it's fine that we do them flipped. Can you please post a link that is in the instructions? The bit link is taken. Oh, thank you, Neha. I see that you're replying to that. So Anita, did that answer your question? Okay, so I'm lowering everyone's hands. Can I do that? Okay. Priya, that's a really good question. So this workshop license, it has a duration of 2 weeks, so you can use it for these 2 weeks and play around with your code. And if you have questions about accessing a license further on, we're here to help. You can ask us. Okay, so are we all ready in MATLAB Online? I'll share my screen in a little bit to show you how that looks. Okay. So I'll share my screen because we don't have a lot of time. But again, if you are behind and you have any questions, please make sure that you type it in the chat, in the Q&A, and my coworkers, Neha and Louver, will help you with that. And we'll start opening MATLAB Online. Which is taking a bit longer since I'm sharing my screen and it's taking some. Okay. See a question from Rishita. Okay, yeah, I'll wait for Neha and Lou to answer that question about the step after creating the account. We can post it in the Anita. Yes, that is the link. What is it not getting through, Anita? Is it not opening the link? Okay, so well, I'll give you a bit more time in a little bit to work on the code so we can continue answering those questions. But for now, let's focus on the example, and then we can, while everyone is working on the example, we can get back to those questions and get you up to speed, or you can, again, get some help from my coworkers. But here you should be seeing this document, right? That it's a live script. And a live script is an interactive document that allows you to have like rich text formatting, images, equations, everything in one place alongside with your code. So that way it's easier to create a narrative and share this information with others and make it easy to understand, right? Or if you're like me, maybe you forget what you did last week. So it is helpful to have more information there to help you remember what you did. So in this case, like Neha said, we're going to be using data from like a phone, right? It was measured using the sensors in your phone, the gyroscopes, and the accelerometers that are those sensors that are typically used for like step counters or smartwatches. And we are going to be creating a model, a predictive model, to be able to do that classification of whether you're walking, you're sitting, you're standing. And the first step that we're going to do, and I know that we call this low code AI. So this code, like, don't worry about it. This is just for me to make sure that you guys are working on the right directory. So don't worry about what it is inside, but we're going to execute this section. And you see that this is a section, right? It's in a blue, in like a blue square, and it has a block here, a blue block. So I can execute the whole section, clicking in there. And you will see if you're in the correct directory, right? So that's why when I asked you to copy this or to open this file, I first asked you to double click on that folder. So you should be seeing this MATLAB drive and then the folder that we're working on. If you don't see that, you'll have to go here to current folder and double click on that folder. Okay, so we mentioned that, and I'll give you a few minutes to do this, don't worry. Let's first work on this together, and then you can execute the sections on your own. And you see that all the example, like the instructions are in there, so you can follow along with those instructions too. But since we're talking about data, right? Like this is what's within data science, you need to use data. So where or how do we read that data into MATLAB? So one of the things that we can do is go here into the Home tab, and you see that there's an option to import data. So we can click on that, and will give us the option to select which folder or which data set we want to use. So we'll go into additional files, and you'll see that there's raw sensor data, train, and test. We will be using first train, and we'll talk about that test data in a little bit. So first we'll open that one, and it will load into our workspace, right? So first it will give us a visual of how that data looks, what are the amount of columns and rows. So you'll see here a bit of a summary of that data. And you can select, of course, which of those variables to import. So if we take a look at it, we mentioned that there's a sensor as a gyroscope, right? Which measures kind of like the inclination, like the one that you used with a phone to see if it's in landscape or portrait mode. And the accelerometer, which, like the name says, it measures acceleration. And we have the data in X, Y, and Z axis. And then we have this train activity. So what this has is the labels, right? So Neha mentioned that this is supervised learning. So we have the data and we have the labels associated with those activities. So we will import this data. Oh, Anita, Neha can help you. You don't have to leave, we can help you. So, okay, now that we have imported the data, we can see in the workspace that it was loaded, right? And again, we can see that it's the same data. We can even double click and it'll open the information about that variable, right? So you can see that it has over 7,300 rows and 128 columns, right? So the rows are the observations, and those columns are the, how do you say, like the time, like the measurements that you do at different time steps, right? So we are going to using this data that was collected from the phone. And typically you want to pre-process the data, right? Data is typically messy and there might be missing data points. We might have corrupted data. There's a lot of things that we have to look for in the data. In this case, we give it like very clean, but just wanted to let you know that this is an important step when we're working with data. And in this case, what we are going to be doing is that, that we had a bunch of columns. So we want to reduce that dimensionality of the data. And one way to do that is by, for example, calculating things like the mean and the standard deviation. So we don't lose like the important bits of the data, but we're still working with a smaller data set. And again, this might look scary, this code, but it's not, I promise. If you see, it is repeating the same steps, right? So it's calculating the mean for accelerometer gyroscope data in all the axes and the standard deviation. And if you don't know what this mean function does, that's fine. You can right click and go on the documentation. So you can ask MATLAB for help, and MATLAB will open the documentation for that specific function. And well, Neha will also be happy that I'm sharing this with you because, well, she's a big fan of the documentation as well. And this is how I personally learned how to use MATLAB. A lot of the documentation, a lot of Googling, and still I've been using MATLAB for over 10 years and I still use it every single day that I use MATLAB. And you'll see that it gives you the information about that function. And it also gives you a description about how that works and what type of inputs do you need to use. And my favorite part is the examples, right? You see that there are different examples that you can copy and paste if that's one, if it does whatever, like it's close enough to what you want to accomplish. But also it helps you illustrate that, right? Like sometimes we might read the documentation and might be a bit confused, but those examples really help visualize and understand what's happening and how to use that functionality. And of course, there are other things beyond how to call that function. So things like learning more about, right? Like what is behind the scenes when we use this function, or if there are any extended capabilities, if we're working with GPUs, for example, if we can use this functionality. So I'm going to stop here and I'm going to wait for you to check the chat and the Q&A and see how we're doing. And we can execute everything until line 28. Okay, I see a bunch of questions about not clear where to click to access. Okay, yeah, Neha, if you want to unmute yourself and if there's anything that you're seeing in the chat that we want to highlight or share again the links, I'm happy to do that.
So Colette, I heard a few people say that is there a license number and activation key? You don't need a license number or activation key. The link that is provided in the chat, I'm going to paste it again. I'm going to paste it for everyone who's asking the question as well. The link that is provided should take you directly to the folder. At most, it will take you to a page which will ask you to create a Mathworks account. So once you're done doing that, because we've created these workshop licenses specifically for this workshop. So hopefully this will help out. Also for people who are stuck, worst case scenario, you can just follow along. You will be getting access to all of this information, and then you can run it on your own later as well.
Correct. And this will be this is being recorded, so you can also like follow along with the recording later on. So yeah, if you're having issues, you can follow along with my explanation and then you can try to replicate it. I see there's a few questions about not being able to access a proper directory. So I want you to make sure that you go to current folder. And let's say that I'm not in the right directory. And if you have copied the file, like in the instructions, you should see this folder that it says WITS 2002 low code AI, and you'll double click on that. So if you, let me just go back to the screen. So this is on this folder that Neha just shared. So that is where you have the option to copy the file. And if that folder doesn't show up, it's because you haven't copied it. So I would repeat this step. Can we run a subset of rows in a given section instead of running the whole section? That's a really good question. Yes, we can. But give me 1 second. I can show you in a little bit. Want to make sure that everyone is on the same page, or at least being able to copy the files and working on the right directory. Okay. So Betsy, I see that you're getting the please navigate to the proper directory. So don't navigate to the additional files, just to the file that it says the folder that says WITS 2012 low code AI. So if it says here additional files, you can just go back to this one. And one thing that it's once you're there on the folder and you open your human activity classification, machine learning, make sure that you execute this first section. All good now. Awesome. Okay. So in the interest of time, I'm going to continue, and we can always check for questions in a little bit, or repeat some of those sections. So we mentioned that we read the training data set, right? And you might be wondering, okay, what do you mean by that? So when we're working with, let's say we're developing a model like we're doing today, we want to make sure that we have some data in which we can test our model to see if it's actually making the predictions correctly. So we have separated those for you. We separated a training data and a test data, and that's what we'll be reading, right? So as you can imagine, the training data set is going to be larger, and then we just separate a subset into testing. So that way, when we train our model, it doesn't see that data. So we want to see how it does when it looks at new data, right? How well it predicts on new data. So one thing that we can do is to check its summary, right? And make sure that our data set, like we have about the same number of samples for each activity. So once we execute this, we'll see a summary where it says, okay, how many data we have in each of those categories. Give me 1 second, because it doesn't seem, I'm not sure I executed this. Okay, having some technical difficulties on my own. I will try to read this, but you should see a summary of that data. So it should show, okay, walking, running, sitting down, and the amount of data that you have for each of those categories. So let me know if you can see them in the chat while we can do this.
Gabby, we have an interesting question. The execute uses local CPU, right? I'm going to let you answer it.
The execute, what do you mean by execute?
I believe, so when we run the code, are we using the local CPU, or like what is being used?
So in this case, we're using MATLAB online, so it's executing on the cloud. I'm not sure if that's what we're looking for.
Priya, is that, yeah, okay.
Okay, awesome. Yes. So let me just run this preprocessed data real quick. Oh yes, I need to, well, my data. So I will cheat here a little, and I'll show you what I mean by cheating there. I'll pre-process my data. I'll work on the summary. Excellent. So this is what I was mentioning, right? Like we have a summary here of the different activities that we're doing. And we need to also read our test data, right? So you saw that we use this import data tool to import our data, but now we can also use this programmatically. So I wrote this line of code that does the same thing. It reads my data into the workspace, but this is a testing data set, right? And you can see that the number of samples is smaller. Okay, and here we're repeating the same steps. So we're calculating all the means and standard deviation, and we're combining everything into one array. Okay, so now that we have read our data, right, both the training and the testing data, we will train our models. And we will be doing this by using an app called Classification Learner. So this app can be found here on the tab called Apps. And we see that there's a bunch of apps listed here, not only in like machine learning and deep learning, but in other areas. And like I said, today we'll be focusing on a classification problem since we're classifying into different activities, and we'll be using that app. So you can find it here on the apps, or you can execute that section in that line of code calls that classification learner. So it might take you a little bit to open. And you see that these apps are user interfaces, right? That allow you to follow this workflows that are advanced workflows in an interactive way. So that way you don't have to worry about the code that is happening behind the scenes. And you see that none of these, I cannot do any of this yet. It's easy to see where to start because it's highlighted. So I will be using data from the workspace, right? The data that we have loaded for the training. So let's wait for it to open. Who creates and maintains an amazing array of apps? Yes, we have an amazing group of developers that create those, and a really good group of UX developers that make sure that it looks nice and that it makes sense, right? That people are easy to follow and are intuitive. So I think my bandwidth, I don't have a lot of internet bandwidth, and it's slowing this down. So I will be using MATLAB on my desktop to continue this, and I have the same code. And since we use MATLAB Drive, it syncs onto my desktop version. So let me just zoom this so it's easier to see. And I have this classification learner app open here. So we'll read data from the workspace, right? And it'll give me some options to read the data. So we have this activity data train, which is again the training data set that we're using. And then we'll say again, what is the response? So in this case, you remember we had that column with the different categories. So we'll be selecting that train activity, and you see it already knows what I need to select. So it helps me with that, selecting it depending on the type of data that it has. Here I have other options. So in case of validation or testing data, so the validation data set, it's a data set that it'll use to check as it trains to see how my model is doing. And I'll just leave this as a default, but if you want to read more about, you'll see that there's a lot of hyperlinks in there. So while the data loads, you'll see that in a little bit, like the other options will pop up and will be in color. There you go. And we'll focus on this one because here's where we can select what type of model we want to use. So let's say that I have I know what type of model works well for this, but if I don't, I can just select all. And today, for the sake of saving time, we'll do all quick to train. If you want to take advantage of GPUs or like you have a big model and you want to use a GPU, you can definitely take advantage of use parallel or even like use a course of your computer. We'll not be using this right now since it's a very small data set. And I'll train null. Halima, yes, there's an instruction. So actually the live script, they all have those instructions. So you see that it has all the screenshots, so you can follow along on your own time. And actually at the end, it has some recommendations also to, if you want to expand this and move forward into more advanced projects. So right now it's being queued, but you see that now some of these trainings are being already, these models have been already trained, and it gives me how good they are, right? The accuracy. And one of the things the ways in which we can visualize this accuracy is in a confusion matrix. So you see that it tells me the predicted class and compares with the true class. And it's ideally every observation would be on this diagonal, right? But it's not the case. You see that for laying, which makes sense, right? Like laying should be easy to differentiate. Like all of the predictions were correct, but the ones in walking weren't all that good. So we can use this data to see, okay, what I can do to improve this model, right? Like this might need some improvement, so we can work on that. And you see that it will highlight the model that it has the highest accuracy. So that makes it easier for you to select and explore. Since we don't have a lot of extra time and we still need to go to deep learning, there's a way to also generate code from this type of apps. So that way you don't have to write the code behind the scenes, or you don't have to like replicate the step every time. So you can even share that code with others so they can replicate it. So Neha will show you how to create those, how to generate that code in deep learning. So she will be using an app there as well. But yeah, you can pretty much export them. So Neha, if you want to continue, we can move into the deep learning section, and we can always go back.
Yeah, so and while we are switching screens, I would like to answer the two questions in the chat. Mary White says, this is amazing. Thank you, Mary. I will definitely pass this along to the relevant dev team. It's always good to get positive feedback, and Joy as well. Anna asks, what is usually a good percentage of accuracy in this project? This is a very good question. And the most correct answer to it is, it depends. No, it's not the one you're looking for. See, we don't have a lot of data technically when we're working with this, because it's a dummy data set, because we need to run it, and then there's so much bandwidth stuff involved. So we need to keep our data sets very small. So you're not going to get a very good accuracy. And if you are, there is definitely going to be some form of overfitting involved. So if you don't know what overfitting is, I'm going to let Gabby write it in the chat. If anybody is interested in knowing what overfitting is, there's a fantastic meme, and if you just Google it, you'll be able to find it. Maybe Gabby can find that chat, the one. She knows what I'm talking about. But overfitting does happen when you have a very small data set. Like think about it. If you just show your computer 10 images of a cat and then put a picture of a chihuahua, it's going to call it a cat, right? Because that says the 2 ears, it sees the eyes, the whiskers, and it's well, I guess it's cat. So you need to that's why you need more data and more domain knowledge. Where do we get the data for our projects? We look at open data sets online. It's the short answer of it. We do not collect our own data. We look for open data sets because they're more standardized and more, efficient. I believe there's a link. So if you look at my screen, which I believe everyone can see, can everyone see my screen? All right, and you can see the deep learning one, right? Because I have MATLAB, right, Gabby? Okay.
Yes, I can see that.
Fantastic. So if you look at my screen, there is a link, information about the data set that we've collected. Most of these are available online, and you should be able to get them fairly straight. It's a fairly straightforward way to get them. So, all right, so let's move on to deep learning. Now, Gabby did a great job in showing you how you use machine learning, and you can now understand why this is low code AI, right? It's because you're not really writing anything, we're just using these apps, and this app is going to generate code for you. So let's jump right into it. Now, difference over here in the first, for the machine learning bit, we calculated the means and the standard deviations because those were our predictors. Remember, I said that you need to tell the algorithm what you're looking for. Over here, we don't really need to do any of that. So another question that people had was sometimes you're not, so what you can do is just right click on the folder that you're in. So if you go onto MATLAB Drive, mine says this one is low code AI. You right click and say add to path, selected folders and subfolders. That should ensure that whenever you're accessing files within the folders and the folders which are inside the additional files which have all of the data information, it will, there won't be an issue. Paths have been set. You're pointing it in the right direction. Now we're going to open human activity classification _ DL. You should see the title right here. And if you haven't already, you can hit clear. And then that's going to clear out your workspace. That's just good practice. I am going to, there we go. Now we're going to pre-process some of our data. So there's two ways in which you can run it. Gabby showed you over here how to run it. You can also run it in the live editor tab. Let me pin that and say run section. All right. There's also run in advance, run to the end. So if you're looking to run every line of code, somebody asked that question for debugging, that's how you would go about it. All right, so I've run this bit of data. What's it doing? It's loading all of my raw data, the accelerometer data for XYZ axis and the gyroscope data for the XYZ axis. All right, so you have these two, you have the matrices and then you have the test and the train. Now, we need to have two data sets, one where we train our models on networks and two, where we actually test to see if it actually makes sense. And I'm going to give more information on this in a while when we go a little bit into the information. So again, in the interest of time, there's a lot of descriptions here as to how you arrange your data. What we're basically doing is we're creating our data set such that it is arranged in a particular way so that we can import it into our apps. All right. I see something in the chat. Is the chat working on?
Oh, sorry. It was me posting the link to the meme and definition of overfitting.
Oh no, Gabby's okay. That's fine. That's fine. That's adjusting our data sets and ultimately to be able to work with the app that we use, which is called D&D, Dungeons and Dragons fan. I'm sorry to disappoint you with it. It's called Deep Network Designer. We need to have it in a form of a data store. A data store is just a data container that we've created in MATLAB so as to ensure that you're not pulling all your data in. Think about it. If you have 100,000 images that you're working with, pulling all of it into MATLAB is going to take some time and it's going to slow down MATLAB as well. The data store is just going to point to those images and then you can work with them as and when you're accessing a particular image. That's a very basic way of explaining it. All right, so I hope you're following along. We just have to run these bits of code. And now we're going to do the fun part. We're going to open another app called the Deep Network Designer. So just click on that and it should open up. And while it's opening, I'm going to justify why you need training and testing data. One is to account for overfitting. One way to explain it is, let's say you are, you're a professor and you want to assign your students a final exam. You tell your students, here are 20 questions. You'll get like few of these questions in your final exam. Have you really ensured that they've learned everything there is about the topic you're teaching? Not really, is it? Because they'll know those 20 questions perfectly well. But if you ask them the 21st question or the 30th question, they'll be a little confused. That's exactly what we're doing. So we need to have a training data and a testing data in order to test if the training has been done correctly. So for everyone who's following along, if you look at the Deep Network Designer start page, you can see that you can import all of these networks into D&D. We are going to go with a blank network. We're going to create our network from scratch. And this is what D&D looks like. This is your canvas. And right now we have no layers, but we're going to build our layers from scratch. If you're interested, the instructions are given in the live script that we provided you with. But what we're going to start out with is our data is, it's not an image, it's sequential data, it's signal data. So we're going to go with a sequence input layer. So in the layer library over here, I'm going to look in the input section, and I have a sequence input layer. So I'm going to drag and drop it. Okay. As soon as I drag and drop it, you see this information, the properties associated with this layer. Our input size is 6. Why is it 6? Because XYZ accelerometer, XYZ gyroscope. Okay. Now, this is our sequence layer. Now we're going to go into the next layer. So we're going to go into our by LSTM layer, which is a sequence layer. We're working with sequential data. So let's drag and drop that one. Okay. So for the by LSTM layer, number of hidden units have to be 128. And when we scroll down, there's an output mode somewhere. Oh, it was up here actually. So I want to make it as last. Okay. All right. Now, after this, we're going to add a fully connected layer, which is going to come in from, Jesus. Okay, we're going to just, I'm going to find it. I don't know where it is. So let's make use of this fully connected layer. Our output size also has to be 6. Make sure you're making these changes as you go along. Then we want a softmax layer. Softmax layer. Then I want a classification output layer. So why classification output? Because we are doing classification. So here are all the output layers you have. We are just going to take classification layer. All right. Now we connect it. It's fairly straightforward. It's a straight 6-layer network. There's a button called auto arrange. So let's auto arrange it. If you hit spacebar, it arranges it. It fits it to the screen if you're interested. Now you can analyze. I'm going to speed up a little, but you should be able to follow along with the live script later on if you're really looking into this. Now we have this layer. There is no warning. There are no errors. We are good to go. Now, once we move on to the data section right here. Here we import data store because we've already created a data store that contains all our information. Our training data is going to be in DS. I believe that's we're going to have full DS train. This one. And we're going to say, and for now, we're not going to have any validation data. Immediately, it tells me there's no protection against overfitting. And then we can go into our training, and then there are training options that you can set up. For now, I'm not going to change anything, but there are options that you can vary your epochs, your batch size, your learning rate, and so on and so forth. And then you can hit the play button here, which says train. Now, I'm going to not do that because, again, interest of time. However, you see this export button here. This is going to help you generate code. So all of the pointing and clicking that you did, you know what? I'm just going to hit train and then I'm going to hit stop training. When it starts doing whatever it does, you'll see how it starts off. So I just want to show that to you. And then I'm going to bring in my desktop MATLAB and then I'm going to work with that. So let's say I want to stop it. And I'm going to stop it because this takes a little bit of time because it's running on a single CPU. Had I had a GPU access, it would make this much, much faster. And finally, while this stops, I'm going to bring in my actual MATLABs, my local MATLAB. As you can see, there's not much of a difference. This is what it should look like, the training. And then finally, you can export your network. If you hit that export and say export train network and results, they get exported to your screen right here. A great example, I saved my train network because I knew this might happen. And then you can just double click it and it gets loaded into your workspace. And finally, when I evaluate my model, I can see that my accuracy is an 85.9%, 86%. But if you notice the confusion matrix, right, that's where the interesting part is. It's doing a great job with distinguishing between like laying down it's all perfectly correct. There's no error involved. Even with standing, for that matter, you can say it's working out well. The standing and sitting, if you combine, it could be one blob. And all of these three, walking up, down, and just walking, is where the confusion is happening. So you could see that the data is actually not very, or rather it's very close to each other. So the separating it might be an issue, and we may need something more. So I'm going to stop sharing my screen, give it back to Gabby, and answer a few questions as she goes on. Just share. I have questions here. Will I be able to use this data set and do this exercise offline? Yes, you can. You will have access for 2 weeks. Does Mathworks have options for MLOps, ML deployment? Gabby, I'm going to let you go ahead.
Oh, yes. I was actually looking for some links for that. So Neha, if you can help me with finding the links, that would be great.
I'll do that.
Awesome. Yes. So yes, to recap, right, what we did today. So we worked on this problem using machine learning and deep learning. And these apps that we use allowed us to try different models, right? The classification, in the case of the classification learner. In the case of the deep network designer, you were able to create a network interactively, right? Like you can drag and drop the different layers and use that to design your own networks. So where to go from there, right? So before we do that, let's talk about the key takeaways, right? We were able to use interactive tools, so that helps you like follow these workflows without having to be expert programmers, which makes it accessible to people that may not have that expertise or that background in programming. And these interactive tools, since we can also create code, that it's automatically created that shows you what happened behind the scenes, it can help you actually enhance those programming skills, because you can take a look and see, okay, what is happening, and even modify that code if you want to. So, I mean, this was a very simple example, very simplified, but the idea here was to help you get started, right? And understand, get a better understanding of what is this machine learning, what is deep learning, and how to get started with that. But here you can try to improve the accuracy of the models. You can try to collect your own data. Actually, on those examples, on that live scripts, there are some links to other examples, and it shows you how to create your own data, like on your phones. You can download MATLAB mobile and take a walk and use your own data, which is a lot of fun. So if you are really interested in this topic and don't know where to start, there are a lot of free courses available this under matlabacademy.mathworks.com, and we can share that in the chat. But yeah, these are self-paced courses that you can take at your own time, and you can even generate a certificate once you finish. And it's actually a code along, right? It gives you some instructions and you have to follow. But it also has theoretical, like theory information there, videos, etc. So those are a lot of fun. And if you are associated with the university, you may already have access to a lot of other trainings that are more advanced. So I highly encourage you to visit that. Like those courses are fantastic. And also, if you want to connect with us, we're happy to connect and continue this conversation. So this is why I'm putting our social media information in there. And we have 3 minutes, so we can cover some of the questions. We made it.
I wanted to first of all say thank you to both Gabby and Neha. Thank you for your workshop. I think we've learned a lot of information during the time with you, so thank you. And it looks like a lot of people, according to what I saw in the comments, were very excited about the usage of apps to help them implement machine learning, which I don't know if a lot of people are doing as a part of the audience. I think a lot of people have a mindset where I'm going to write code. Eventually you may, but at least when you're starting out, the apps can be helpful. So thank you so much. And you do have a few questions. I know we have about 2 minutes left. So I don't know if you wanted to maybe select a question. Like the topmost question, does Mathworks have options for ML ops and ML deployment? I know that was answered. So I've got a few questions, maybe one more question. Either of you would like?
Let's see.
So I did see a question where someone asked, like, can you show an example on D&D on how you can just import a network? So I'm going to post yes, I'm going to post links to some examples in the chat. for that. So everyone can just get access to that. I just want to sort of FYI over
Okay,
here.
perfect. Excellent.
Yeah.
And I think everyone will appreciate that. And I'm seeing this last question. So the other items are typically comments saying thank you and the workshop was great. So here's this kind of last question. Can we do similar work with Azure, AWS, or any other platform? The person recently listened to some videos on, h20.ai.
Yeah, so I mean, we can take advantage of those platforms as well and execute our code in those platforms. So we're happy to share more resources if you're interested in that, for sure.
Perfect. Excellent. And with that in mind, we are going to switch over to the next work. Thank you once again, Gabby and Neha,
Thank you.
for the workshop. Thank you for the information.
Thank you so much. Thank you.
Take care.